He always thinks he needs to give us a minimum, like we're gonna write 2 words. I was 600. I'm an overachiever.
Like, not bad. I did mine like 325, and I was like, that's good. Is it not working?
I can't come up with 6 questions.
Go ahead, you.
Pictures.
6 cold questions.
Yes.
One of the first ones I'd have to look and see.
I'm not gonna do that. Because the doors locked, they locked it down.
We don't have cards like that.
This is scanning. Yesterday, just that I did.
Oh, really?
And I have.
We just have to break down the door too.
All right, when it's really.
So if you break down one of those, you can't do that. You couldn't cut it. Yeah.
You had to give us people who were not doing all their midterms.
I have it open, Jeremy. Look at it.
No, it's in there pretty solid. Because I locked my keys in there one time. It was like before weekend. I had the Jeep in the deck, so I tried it, and
Was that his or yours?
I just
I was like, when did you do that?
the air filter, take that off, and it's now like this very.
See, it looks like this one ended up looking pretty straight, but when I came in here to edit it,
Show me,
You can get like
oh, they're all like floating up now. I know it's not straight because when I come in.
where are your dimensions?
That's what I can't get because
Y and Z.
oh, like this point.
When you first started out.
Sometimes.
Yeah.
I guess it's. Like I think all my other points are right and everything. I don't know what's going on. It's just like when I place the point anywhere on the line, it's not working.
Yeah, like it just went crazy.
One thing is you have continuous.
Oh, she had to get her,
Oh.
No, he's not that one. Okay.
I have to bug David in order to get the thing that I need.
Middle of nowhere.
They had it all straight, yeah.
That's just
You
mobile.
need to test to grade it. Oh. I'm gonna keep you right under that. Thank you. Great.
When you dimension, are you dimensioning to the point or the plane?
To the point.
You have to dimension to the perpendicular plane.
But if I delete these, oh no, when I do those dimensions out, when I did these, it was to the point, yeah. But when I did the actual like.
Yeah, so you're gonna have to get rid of those
Okay.
because right now it's driving, this reference spline is driving that geometry. And it's forcing all of these to also be perpendicular to the spline.
Okay.
But before you even do this part,
every year.
I know
you
they
need to go back and make sure all the dimensions that are being defined as a set of parameters are actually going to the vertical and horizontal planes of the plane.
Those are going right, but these, just the overall, just like dimensions, those will still positive, those are going right. So should I just delete
No,
those?
nothing should go to the plane.
Okay.
1908.
What does it mean?
Okay.
It needs to go to the planes of the
She
plane.
made it to the
Okay.
World Series like.
You should reference those
Yeah.
too.
That's why it's key.
I had, when they made it into the tournament, I had
You said you're not supposed to
a
be this
t-shirt that my mom had from like.
That's when I delete those, that's when I delete what yours did, I
I was
think.
like rocking it.
We're gonna get started here. If you guys have just logged in, make sure you've downloaded all of the files for class 16. And we're gonna open the version 2 file. Couple things I've noticed from a lot of your bridge submissions so far is that some of you have your actual path is kind of like once you've done the sweep, it's starting to, I guess you could say, twist a little bit. it's not exactly, you know, parallel all the way through or perpendicular all the way through that spline. When you guys are dimensioning, before you even set up your bridge in that solid path, you have to make sure that you are dimensioning all of your dimension strings that have to deal with a parameter. When you are dimensioning to a point, so before we even set up, let me just place a point. Turn on my always. You have to always be dimensioning to those planes of the point, not the point itself. If you dimension to the point itself, it's going to allow your point to rotate once a piece of geometry like your section curve or your section bridge, that box, starts to sweep across the surface. It's going to start to force the rotation of that point. Otherwise, if you dimension to the planes, those planes will always stay in the X and Y axes. So if you're running into problems with a twisting form and or you're getting error messages that have to talk about or kind of your constraints aren't satisfied or it needs to remove constraints, it's a dimensioning error.
Is there a way to fix it after the dimensions?
Yes, you can, with any dimension line, if you select a dimension string, is that screen up there kind of blinking? Yeah. Anyway, if you see this little point that's in the middle of one of the extensions, you can drag that and then rehost it to a particular plane or a point or whatever you're trying to dimension to. If you don't see that handle, it's possible that, like for instance over here, I don't really see that handle. If you take one of these and drag it, you see how in the middle you get that handle again, that point to actually redo the dimension. You can also click on dimensions, and if you right click on that same point, if you had, let's say, multiple dimensions on a string, which, you know, in most cases we all only have just one dimension per dimension string, but you can also delete witness lines. The witness lines are considered dimensions. Or you could even click on a dimension string, and if you click on edit witness line, it allows you to add more dimensions to that string. But in order to add a parameter to a dimension string, it has to be a single dimension. So you can't have multiple dimensions on a dimension string and then try to add a parameter. It won't work. I'm going to reload this just in case I... Okay, so this file that we have open is kind of where we left off last time, but I've added in or completed our exercise. Last time all we did was create these 4 points and then make a reference line spline that went through them that had to have a particular offset that was equal to a parameter called cantilever. I then went through and I've added on this other curve, I added more points, and because this curve was a lot longer, I needed basically an additional set of points other than 4 to really make that work. But all of those are set up the same way, and they have that offset set to cantilever. Then I made another set of curves by placing 3 more points, and I basically just added some parameters to all of these points that have to do with just how I want this to actually look, kind of like a crossbow. And I've got another set of points that are going in the Z direction. They're actually all along the main reference axis. You know, if we look at the level 1, this horizontal plane those points that are going across the top, there's just basically 5 points are forming a curve that actually goes up and above the bridge. And all I did with those is I created more points and I added more parameters to it. So every way that we created the points associated with this bridge, I did the same thing with all of these points by placing new points, adding dimensions to them, and then a set of parameters to define their location. All of their parameters are set up. I'm not going to go into each one specifically, but they all reference some relative position on the bridge. So I'm either referencing the bridge spot elevation, the starting point, or some midpoint or some other hosted point that was already established. This way that if you click on your dialog box and change the bridge length again, right now I think it's set to 1600. You just type in 2000, should see everything grow and expand relative to one another. We can also just go a lot smaller here. All right, so what I want to go over today is how we're going to complete this bridge. I've got a set of adaptive structural components that we're going to place. We're not going to place them all, but just get them started. And then I'm going to go over the actual funky foam form, like you have on your bridge, and how to place that, and a couple different ideas that I have that might help you out there. If you have downloaded all of the other files that were for today's class, if you go into recent files, let's go ahead and open up. I have 2 files. One of them is called adaptive V structure and adaptive box structure. Let's just go ahead and open both of them. So I'm going to open up the box and then go back to view, user interface, recent files. And I'm going to open adaptive V. Let's go into the adaptive box. Does everyone remember adaptive components? We explored those during the curtain panel tutorials. Essentially what I've done is I've set up 2 points. So I made a start point and end point. I selected both of them and I made them adaptive. So that's what those points are down here. This is point 1 and this one is point 2. I then drew a reference line connecting those 2 points. And then I took that reference line and then extruded it. So I'm going to, off to the side here, I'm going to kind of duplicate this again. So I'm just taking these 2 points, I made them adaptive. Then I drew a line that says reference line, and I made sure I snapped to each of those points. Then once I had that line, I just said create form solid. Once you have a solid form, I actually, instead of making this into a complete solid, I was having trouble with actually getting all the adaptive points to go around the perimeter and then do an extrusion. So I actually made this solid by a series of faces. So once you make a face where basically what I did here is I extruded this up, you can then tab over and select one of the edges and say create form again. And I can do the same thing. And of course, this one I can change the direction of it from your positive and negative offsets. Number lock. And so I basically completed the whole entire form by, and then to close it off, if you just select both. Now you'll see that when I selected both of these edges, I now have these 3 thumbnails that popped up. They both, I'm not sure what the difference is between the first 2. They both look like pipes, but the last one's a flat plane. And then I did the same thing to close it off. So I basically made this whole box in a series of faces, kind of like you might do in SketchUp or even in Rhino from time to time to make that solid. I'm going to delete all that. The next thing I did is I took a dimension line I did a dimension from point to point. And remember, I just got done saying you have to dimension to the planes of a point. Well, in adaptive components, you have to dimension to the point itself, because remember, adaptive components will be rotating. Those points will be rotating, so we can't force it into locking into those perpendicular planes. So I actually snapped to the center of each of these points, and I set a few parameters up. One of these is called structure width, length, and depth. I also added a material parameter. But one of these parameters, and they're actually all defaults, meaning that they're all instance parameters. One of them is a reporting parameter called structure length. And that's what you see highlighted, and is actually reporting what the length of this structural element is going to be from point to point. The reason I did that is I want a parameter set so that the size of this box is being developed by the overall length of this beam. You all remember from structural classes, or even just in studio when you're trying to show some realism to your projects, there's one of those magic formulas where you take the overall length of how far you're spanning a beam, you convert it into inches, and then add 2 inches or subtract 2 inches or some kind of rule that gives you a general depth of, you know, what a beam might look like realistically, so you don't have to do all the structural calculations. So that's what I set up here. I basically just say structure length divided by 12. That makes the depth, turning this into from feet to inches. And then I did my structural width. I just came up with some obscure multiplication of 0.125 that gave me a particular thickness or width to the beam that I wanted.
What is ABS?
ABS is absolute value. So I just wanted to make sure that this number is always positive. I guess your structural length wouldn't, would probably never be negative, but from time to time I like to force a positive just to ensure that you always get, you don't end up with negative numbers. And on our class website, under resources, I put a math section. You guys might want to review that. That gives you all these abbreviations of what you can put into formulas. So if we take this and load it into the project, I'm going to load it into Bridge Tutorial, that version 2. Then I'm going to flip into a 3D view. And what I'm going to do is go under Home and then Component. You should see that you can select your adaptive box structure, which is the file we just loaded in. And we want to place it on a face, so make sure Place on Face is set under Placement. And then you can hover over one of these purple reference lines and snap to that point, and then click on another reference line and also click on that. And you see it basically just drew that box beam. We are making that adaptive and hosted to those reference lines. Say that again.
How did you select that family type once you loaded it in?
I go under Home and then Component. So every family that you load into a project will always be found by going to Home and then Component.
Would it always do it perpendicular?
It's going to be, when you start to snap this to the different points, it won't exactly be perpendicular. It looks like it is, but from time to time, especially when we get to this next adaptive component, you'll see that you may have to, from time to time, hover over the point, the adaptive point, and then you can move it by dragging it. Or you can also move it by your normalized curve parameter. So right now that point's located at 0.57. I could type in 0.6. So if you need to make any adjustments once you actually get this component placed, you can just tab over and find those points and then move them. Now once we have one of those placed, we can hold in the control button and select or hover over that item and then just drag. And you can keep, by holding in that control button, you're basically dragging and dropping each of these or sliding them up and down the different reference lines.
If my beam is connected on the bottom and kind of goes across like yours is on the bottom, but mine is connected by the top.
Okay, so you can click on the beam, and under adaptive component, you can hit flip. It probably had to do with the order that you snapped. And so when you kind of rotate around, you should see that as the beam gets starts to span less, the depth is also changing. So all the depths are not exactly equal, and that's because of that reporting parameter. Now you might say, well, so I can drag all these, but how do I actually get them kind of equal, and try to have some sort of logic to their spacing? Once you actually place an adaptive component, if you go into like a floor plan view, while we're in the floor plan view, also highlight level 1 in the project browser, and then under view range hit edit. Change everything to unlimited except for the cut plane. Let's go ahead and just make that like 2,000 feet, just to make sure we're well above. And if you don't like the thickness of how far these beams are going in depth, and then also how wide they're getting, you can obviously just go back in and adjust the formulas that I have within the adaptive component. I kind of think they're a little thick right now, but we'll worry about that later. So once you've actually placed these beams, what we can do is draw in the floor plan, let's draw a series of reference planes. So under the top here, click on plane, and we're going to draw a line. And I'm going to snap to the endpoint and draw a vertical line. I'm basically going to make a series of guides. The next plane I draw, I'm going to snap to the other end. I'm going to call these kind of my construction lines right now.
What points are you selecting?
I'm just snapping to the endpoints of this curve. And then if you take one of those planes, I'm going to copy it. So hit modify and copy. and then make sure multiple is selected. You cannot array a series of reference planes or reference lines, so that's why it's grayed out. So unfortunately we have to do this by doing a copy and multiple. And I'm going to copy a whole series of these. I don't really care what the distance is at the moment between them. And then if you dimension to each one of them with the align dimension tool, when you're done, you can just click on equal, and it'll make it equal, equal, equal. Now, I'm not going to do all of these beams, but once you set up this adaptive structure, you're going to have to do a little bit of work in creating your alignments correct, or the way that you would like to see them in your design. So I would like all of my beams to actually be vertical in this plan view. And so since when I drag my adaptive component, basically it's trying to connect the normalized curve parameter value equal on each side of the curves, and because my curves are different lengths, that's why you end up with your adaptive component starting to kink to one side or the other, because it's trying to connect the 0.78, and this one's probably, well, that one's 0.95, but it's trying to be close anyway. But once I have that, what I can do is I have these reference planes as a guide. I can then drag the point. I have to tab over to select that adaptive point. And I can get it, fairly close to the location I'd like to see it in. Once you have this hosted and it's actually connected to these reference lines, no matter how your bridge ends up changing, it's always going to remember the normalized curve parameter value of where those adaptive points are located. And so those beams will always be at those locations once you have them set. I'm just going to do one more here just so you can see. So I tabbed over, I selected the point of the adaptive, and I'm just, you can't really snap to the intersection of these planes, but I can at least eyeball it and get it fairly close. And you can also use your cursor keys, left and right, to move the point if you just want to nudge it over a little bit here and there. So anyway, you kind of get the idea there. So you can kind of determine how many beams you want. These reference planes, they're just there for this alignment exercise. Once we're done, we can select them all and delete them. They're not really serving a purpose other than a visual overlay at the moment. But if we go back into our 3D view, I want to go ahead and place these other adaptive components. So I might hit save. And I'm going to flip over into the component called adaptive V structure. And I could have made this all into one component. I might try that again, but I was having some difficulty with the beam versus this component and getting it to flip in the right direction. So that's why I made them into separate components. So you may have to kind of break down your structure a little bit to get it to work correctly. For some reason, when I actually had the beam down here, when it got placed onto the bridge, the beam part flipped up above the bridge, but then my V was still upright as well, and I could never get it to flip correctly. So that's why it's broken up this way. So adaptive components, they're not perfect, but we have to find a way to work around them. This particular structure is set up like basically a series of cables that are moving from 3 adaptive points. So I made a triangle, and there's a series of dimensions here as well. They're all reporting, there's 2 reporting dimensions and 2 instance dimensions. I'm basically finding the length, the overall length between each of these points. So point 1 to 2 and 2 to 3. That then determines the thick or the actual radius of the pipe. So if you look, I actually called it diameter. It should really be called radius. But anyway, there's a parameter here that's set to the actual thickness or the dimension of that pipe. So basically, as the length changes, the thickness of the pipe should also change as well, just for some more variation. We can go ahead and load that into the project. If we click into a 3D view, basically what we want to do is we're going to connect those 2 reference planes that we just connected with our adaptive structure beam, that box beam, but we're also going to include the wire that's up high as that center point. So I'm clicking on Home Component, and because we now have more than one component selected, if you click on that kind of that big button off to the top left under Properties, you'll get a pull-down menu now that shows you all of your different components that you've loaded and what you can place. So I'm going to make sure I have adaptive V structure. And the order is, we need a low point. So I'm picking a point here on this kind of this bow. And then I'm picking another point up high. And then I'm picking a point on the other side. And so this works in the same way. We can, once we place one adaptive component, you can actually just hover over it, hit Control, and then continue to slide this. And now what I probably should have done is, if we had all of our beams set exactly how you wanted them to be, you know, we actually went through the whole exercise and you aligned all of your beams to be vertical in the plan view. When I place an adaptive component, so I'm going to right click on one of these and say create similar, just so I can make another one. I could actually snap to the point of another adaptive component. So I could snap to that, and then up here, and then down on the other side. And at least it'll be aligned to all that work that you just ended up doing to get the other beams to be aligned. It doesn't form a connection between the adaptive components. The adaptive components always form a connection to those reference lines. So you can see after I snap to those points, if I drag the beam, the other adaptive component obviously doesn't move with it, because these points are being hosted by those reference lines. So that is kind of a quick and easy way to add some tectonic structure to your path. So it has some realism of, you know, there's obviously something kind of holding up this curvy path that's spanning, you know, close to 2,000 feet across a waterway. I chose to make kind of a arc above and then kind of have a suspension bridge. I could have also made this where, you know, I have an adaptive or a reference plane that's underneath, and you could have some structure coming up from below. You can decide how you want your structure. I think I emailed you guys some images. I don't know if you got it in your email, but just have some quick little inspiration when you do an internet search on complex bridges. You can kind of see some of the forms. Let me load one up real quick. And that was kind of my inspiration for what we're going for here. Obviously this one's a little more complex, a lot more parts and pieces. But, you know, it's pretty nice, has some glass panels in there eventually. Then you can also see there's structure underneath. So you can get as elaborate as you want to. One of the other images I sent were just some, kind of Revit models. You see this one's a little more delicate, a little more kind of nice, where it has these rails that kind of catch the beams on either side, and it's got this arch going over and hanging a couple cables. This one's a lot more elaborate. So you guys can get as creative as you want to, but as long as you follow the rules with the adaptive points, making all these different components, as long as you have these reference lines, you can add as many of these structures as you want. And now that you have all these set, if we come back into our properties and change our bridge length, so I've got 750 feet typed in now, I'm going to change it to 2,000. Now, it's going to take a little bit longer to generate, but you can see it's stretched, and all of the structure stretched into the exact location of where it was in the normalized parameter, or that curved parameter along the reference planes. So it moved my... Somehow it moved that guy. Why did it do that? I kind of kinked all of my structural elements. Didn't do that earlier, of course. Well, the point would be, at least you can find your overall length of your bridge that you're working on, and probably to lock this in place, and I wouldn't want to have to do this, but you'd have to come in here, and there's no way to lock that normalized parameter unless you associate it with a actual parameter that's already established. So you probably don't want to do that. Anyway, you'll have to play around with that a little bit. It's not going to be perfect. Maybe if I delete, hold on a second.
It's possible, since the lines are different lengths, that one might get scaled longer than the other. So it might be definitely the same point on that line, but it might be larger than the other one anyway.
Yeah, that's what I'm, let me see if it's still on the same. So it's 0.894, and if I change this again, oops. Yeah, it's still on the same, yeah, you're right. It's still on the same point. It's just those are being scaled up and down.
Is there any way to keep it from kind of rotating like that? Like when we're kind of copying them over, they're angling a little more in general?
No, so this one that goes up and above, as you copy them over, you notice that it's starting to angle over. You're going to have to do the same thing where you kind of tab over one of those points, and then you can move that one point into place. So I would do that in level 1.
Is there a shortcut key in Revit to stay orthogonal?
To
Like
do what?
besides using the guides?
A shortcut key for what?
To stay like perpendicular or?
Not in this case. There is for various snaps and things like that, but it's not going to do it for the adaptive component.
So would you say it's probably best to figure out how long our bridge needs to be, and then just like keep that length locked in there?
Probably for now, with the theory that obviously you could adjust it and you might have to do a little bit of legwork. The other method could be, I could actually create, like it. I was going to try to create a surface and then divide it. So that might be a possibility too, where if it allows you to make a surface, you might be able to come in here and do a divided surface and then apply a curtain panel to it to give it some structure. So you might have to play with the way that the grid is rotating and so forth by all those different parameters off to the left. Kind of seen it done both ways, and I suspect those two images I just showed you are probably a combination of these two. So you might play around with whatever works best with your particular bridge to add some of this tectonic structure to it. The last item I want to do is let's go into our view and user interface recent files and go ahead and open the analog to digital translation file. This is everybody's infamous canopy curves, and we've all set them up the same way where I believe we have, where you basically found a point referenced on your bridge, your actual analog model. That was probably some corner, and that's the way I did it as well. And then you have all these X, Y, and Z dimensions that defined where each of the points are located. In your family types, you had all your X1, your Y1, Z1, and so on and so forth, probably 10 points or less or more. Well, the issue is that you built your curves based on some assumed dimension and length of your bridge. So when I scaled my bridge, my overall length at 16th scale, my overall length was 240 feet. And so all of my points in between are some point in between 0 and 240 feet, and that defines the actual scale and positioning of all those points in that canopy structure. So what we have to do now, because these points are set up this way, is actually find a method excuse me, to scale it. Now I've got 4 different points here curves as an example. If you look at my model here, I did this surface, so that's surface 1, bottom and top. And then if you look at the family names, I did this other edges of this surface called surface 2, left and right. And so when you select all of these different family types, you can see the X, Y, and Z values keep changing because it's all based on what was programmed in. And so all of your curves are in one file, or they don't have to be, but they can be. Then, down below, what I've done is I've added a series of parameters, and it's going to take a little bit of time to set this up, but once it's set up, it works. Up at the top, you'll see that I have some constraints. One is called total initial length. I have that set to 240 feet because that's what I assumed my bridge was going to be at one time. I added another parameter called total actual length, and that one's an instance parameter. So it has a default. I also set that to 240 as well, just to keep everything the same for now. Now, because when you change from curve to curve, I can't put in any formulas associated with these dimensions or these actual points that were first established. If they are changing from one form to another, all these different family types, if I enter in a formula, the formulas always stay consistent from family to family. You might have noticed that if you've experimented a little bit. So basically, if I put in a formula here, no matter what I change, that number would always be the same. So what I want them to be is different for each family type. And so I created down at the bottom an equivalent parameter for each of the points. So unfortunately, if you have a lot of points, there's a lot of parameters to make, but I spent 15 minutes, set all this up real quick, and my parameter, so I basically called them whatever the same point was called up here, and then I just put an SF after it for scale factor. Doesn't matter what you name it, but these are all instance parameters. And the formula for each of these is, I guess I need to zoom in here. So for one of these, the Z10, I'm doing Z10 times scale factor, Z9 times scale factor. All these are times a particular, or multiplied by a scale factor. Then down at the bottom, zoom out. I set up a scale factor instance parameter that's called total actual length divided by total initial length. That will give you, right now, a value of 1. And so as that number changes, you'll have a scale factor where it'll either scale up and down. After this, I'm also going to not show you, but talk to you a little bit about maybe another method of how we could have set this up. But since we have this all set up this way, this is the way that I found to make it work so far. You had a question, David?
Yeah, do you have to do that for each family type, or do you do that in one family type and then all those get copied to the grass type?
Well, remember, yeah, so if you just do this in one family type, if it's a formula, the formulas are consistent from family type to family type.
You have to do it on the original curve though, I think, because otherwise it won't set. That is what I discovered when I set up my bridge.
What do you mean?
Like whichever curve you made on here first, like whichever family type, if you don't set it up on here, it won't apply, it won't save once you cancel out of it. Isn't that the problem we have, Kristen?
I've no idea.
It should. It's possible that it wouldn't let you. Did it give you something, your error messages about type parameters trying to reference an instance parameter and things like that?
I think it said it was trying to, it was like curve C trying to reference curve A or something like that.
Yeah, they were trying to reference one another, but we weren't doing these parameters. We were doing something else.
We were doing like the bridge path.
Yeah, it should work okay on this as long as you set up basically your total initial length, and you notice that this is a type parameter, and this is where in Revit there's some things that work sometimes and sometimes they don't, and people don't have explanations why, and I don't for this. This is a type parameter and this is an instance parameter. They're being used in the same formula down here, and this is an instance parameter, and I didn't get an error message that said I'm trying to reference a type in an instance. I don't know why, but if I did it in a different order, like if I started over again and then did this in a different order, I got that error message. So the point is, if this is causing you an issue, it works for this particular file, but this might have to change to an instance parameter and make them all, anything that's in a formula, make it all instance parameters. The reason I kept it as a type is I wanted the 240 feet to always stay 240 feet, because from every single initial curve that I set up, it was all based on my original model. Okay, so I have all of those. I'm going to load this into the bridge project.
These don't have reference points, correct? So like, we did these curves and then we set them up to a reference point. Is this pre-setting up to reference points, like these are the original files?
Yeah, these are the original curve files before they got hosted into another family.
Okay.
So you might want to go back to that standpoint. Now, my path example that I've been showing you doesn't reflect my model, because I just kind of did this real quick in my head without my model. And so when we place these canopies, they're not going to align perfectly, but they will if I would have actually, measured out my path and we were actually working with this path during class instead of one I made up. Now, if you go, I'm just going to flip back real quick, back into that curve type. All of these are being referenced from this origin, right? This center origin of where these planes cross at that 0, 0 origin, that's where all of these different points were located from. When it's in our bridge file, we want to set up a point that's going to act as that origin point. So I'm going to just get into a plan view and click on a point element. And I'm going to hover over this vertical reference plane, the one that's dashed right here at the 0, 0. And I'm just going to put it some distance above the bridge. I'm also going to select it and turn on all of my planes. Now the reason I put it above is when I'm looking at my original file, everything was going up and to the left. So right now, if this is imagine that as the crosshairs, my curve is going to be going up in this direction. Okay? I'm going to explain a little bit more here in a second. What we want to do is under Home, click on Component, and you should now see the ability to select that analog to digital translation file. And we're going to want to place this on a work plane. So this time I'm going to say place on work plane, and we need to pick may have to be in a 3D view. Yeah, you need to be in a 3D view, sorry. So do that again, go in 3D view, do Home, Component, place on work plane, and then we get the option to pick a work plane, and we want to pick the horizontal work plane of that reference point. Then it's going to want you to place and snap that point, and you can see the cursor has that relationship to wherever that reference plane was or that origin point was in the original file. I want to snap to the center of that point. So in that case, I placed the surface one top. Let's go ahead and do that again. Home, Component, but this time choose surface one bottom, or if you need to pick the opposite one, whatever one you placed first. And I'm going to do place on work plane, pick that same horizontal work plane of that point, and also snap to the center of that point.
Whenever I try and bring in one of those surface curves, it's snapping somewhere to like the center of my model. It's not allowing me to kind of snap over the point that I placed.
Do you have a place on work plane?
Yeah.
You may have to rotate around a little bit in the view, see if that helps. And you might want to move your point, further away from the bridge, maybe.
Well, it's like it's already snapped somehow. Like, see this dimension line? It's like it's already snapped to a point somewhere in the center of the component. So snap a point here.
I'll go to make sure you and then pick that horizontal plane.
Yeah, the scale.
You were trying to, it was wanting to put it on the level 1 plane. Oh, okay, so that's why.
Awesome.
Good effort.
All right. Does everyone have those two curves? Yes, no? Okay. Now, you'll notice that our bridge is going off to the left, but our curves are going up to kind of the top left, just like our original file for those curves. So what we want to do is select that point, and under rotation angle and properties, go ahead and just type in 90. And it will rotate those curves to be in position and going in the same direction as our bridge. Okay. Last step here for these curves is if you select one of the curves, if you look over to the left in the properties, because we made the total actual length parameter an instance parameter, it is over here, meaning that we can edit this parameter here in this file. But what we really want it to do is equal the overall length of this bridge that we're trying to place it to. So right now it says total actual length is 240 feet. If I click on this button to the far right, we want to set this parameter to say bridge length, and then hit OK. Do the same thing for the other one. Click on that button and then make it equal to bridge length. You see how those now just scaled up to be in relationship with the actual scale of this bridge. And then we can select both of the curves and say create form solid.
What if like our path kind of changed slightly because we adjusted it and it doesn't fit?
Go over that. So once you have that, if you type in a new bridge length, maybe I'll say 2,000 feet. I will see this actual canopy structure also scale up as well. Now the only thing that we have to do is this reference point that we've placed right now is just free floating, and it has no relationship to the position of the bridge as it grows. So what you want to do is go back to your original model, and you need to come up with a scale factor of how far away that point is from, remember we set this bridge up to have its origin point at those reference planes right there at the middle of the path, the start point of the path. So since I'm trying to now measure to this corner, my original dimension here was something like 63 feet when it was at 16th scale. If you guys are looking back here real quick. So I took this measurement. That's how I'm going to come up with my scale factor for where this point needs to be located in the y direction away from the origin. Right? So I just need to know where this point is located. As this scales up and down, this point should always be in relationship to wherever this path and everything ends up growing.
Where do you set that up? So like point.
Right. So we have this point that's already placed. And I'm going to draw a dimension from the reference plane, and in this case I really do want this to be to the point, not the plane, because we just rotated that point 90 degrees. We have to now just snap to that point. This way we could always rotate this point again. We could rotate this point. So it's 90. I could make this a 45-degree angle. And you notice I don't get any kind of constraint problems. Now in the family types under properties, I don't think I have it in here. I would want to set up a let's add a parameter called, I just call it like Y align or something like that. I'm also going to group it under analytical alignment just to keep it separate. And I'm going to set that dimension string to equal the Y aligned value that we just created. Then what I might want to do is find out where this point really needs to be. So if I had a scale factor and if I had everything aligned correctly, you know, if I had the right path in there in my actual canopy structure, I could just come in here and give it a dimension that said like bridge length times some, you know, 0.25 or some kind of formula. So I could type in 63 feet divided by 240, because that would give me my scale factor of my original analog model, and that would be the value that I'm using. But some of you, and even myself here, might have changed your bridge path design, and you haven't changed any of your canopy structures. So what I'm going to do is find out a location of actually where I want this canopy to occur. I'm going to delete this dimension for a second. If I take that origin point and I move it, I can drag this form around to find out where I'd like it located before I start to assign parameters to it. I could also come over here and hit flipped. You could flip it around. I could also rotate my angle. So maybe it's not the full 90 degree. I could play around with the angle. Maybe this is something more like 310 degrees. So you can play around with the position of where this point is located to change the location of your canopy structure. And so you might have one reference point for every canopy surface that you have, unless you know, you've got your path and everything matching up pretty correctly. But you see I kind of flipped it around, so I rotated my point 310 degrees, and I moved it around, and I've got a form that I kind of like that actually works with my new path. Once you do that and you've located where that point needs to be located, that's when you can come here and start to snap your different dimensions. And then I'd want to come up with some, I'm going to change my Y align to 0 again. If you have your parameter set to 0 at the very start, when you assign it, it takes on whatever the value is of that dimension string. If you start off with a dimension in the parameter, it forces the dimension string to that dimension. And so since I don't really know what all those dimensions are for that point, I'm going to make all this at 0. I'm going to do another one called X align. And then I'll do a Z align. Then if I select this point, my Z is the offset. Then I can set these dimensions. This is my X align. This one is my Y. Now that I have those values down here, I could come up with a formula. So if my bridge length is 2,000, let me just give a let's say bridge length times, okay, pull up our calculator. Just going to do, I'm going to round it up, just say 654 divided by 2,000. That's my scale factor, 0.327. 0.327. Do the same thing with all of these. Then now, because it's associated with a part of the bridge, which is the bridge length, you can see that bridge length can drive a lot.
Why did you take 490 divided by 2,000?
Because the total bridge length that I have at the moment was set to 2,000. That was the dimension that was being read of where that point was located.
And 490 came from?
The dimension string.
Oh, okay.
Of when I dimensioned to that reference point, when I looked at when I set it to align Y, that
It was the-
parameter, that was, it said like 489 something, so I just rounded up to 490. Get kind of close. So now when I change my length, everything should scale, and that point will also move. And you can see it still looks correct, or close to correct. Now you're going to run into a few issues, because if your bridge starts to slope up and down, you know, your bridge could end up sloping above and through the canopy. Because right now I've only set my canopy to be in reference to a particular bridge length. So maybe my bridge Z, right now I had it set to 0. I might want that set to bridge some of the z-axis parameters. So bridge spot elevation start, since it was set to 0, maybe I want some value here of just typed in like 00006 or something. This way that if my elevation of that start point moves up, 640 feet or whatever, my canopy reference point will also move with it. Okay, that's a method for getting all of those to work. If I had to do this over again, because this is all kind of exploratory and experimental stuff that we're kind of working on here, I probably would have, as we documented the position of all of these curves, maybe made it relative to some point that was actually on the bridge, maybe like a center point, or let's say this canopy structure, I know it's kind of in the center, so maybe I should have set up all the X, Y, and Z dimensions to be based off of that as my reference point, and then set up another set of curves that have, the reference point is over here, something like that. And then this way you could you could actually just place a point on that spline of your path, and because it's hosted, no matter how far your bridge length expands and contracts, you wouldn't have to like type in all those formulas to find out where that point needs to be located in space. It would always be connected to the bridge. That would be probably a better way of getting these canopies to stretch and move, and also be parametric with the bridge. But since we kind of did this all backwards, reverse order, at this point for it coming together, that's one method to get it to really work, is what we just went over in class. you're welcome to go back and try to rehost it, you know, come up with a method that works for you. But since you already have all your points programmed, you know, it might just be good to get it to work, you know, at least one time to stretch across the river. The last step is, okay, we've done all this, we need to bring it back into our Revit file. I'm going to set my bridge length back to 1,643 feet 8 inches, because that's what our original length was that we found on the actual topography surface. So 1,643 feet 8 inches.
Do we change our elevations?
No, we don't have to do the elevations yet. And you can actually do all of your, keep the elevations how they are. And click on OK, let this thing grow and do what it needs to. I'm going to save it. And now under View User Interface, we're going to open up a project. Did you guys download from class 14 that bridge tutorial site model, the RVT? You guys have that already downloaded from class 14? Open that. If not, go ahead and download it from here. So I'm going to open up that project file, site model. Remember this is where we started? I'm going to close some of these. I'm closing out all of my other families. You guys don't have to do this, but I'm just trying to clean up my workspace real quick. And so if I take my bridge tutorial, this actual bridge, and load it into my project file, give it a minute. You're going to get that message that you have to turn on your masses. It does that automatically. And then I'm going to place it on a work plane. By default, it says place on face. We want to place it on a work plane, and we want to make sure it's being placed on datum 00. Remember the datum 00 that we set up? That's just basically a level that's on the 0 elevation mark. Then I'm going to snap to my start point. And when you zoom back out, you're not going to see the bridge anymore. You turn on your wireframe, it's down below the topography surface because we just placed it on the 0 plane. It's also rotated, you know, so it was horizontal while we were working on it to that reference plane. So we need to select it, click on rotate. Remember, you have to move your rotate icon. I'm going to go back to this point. Then if I start to hover my cursor kind of in the orthogonal direction, you will see that it will actually pick up that reference plane from this actual bridge file that was horizontal. I'm going to click on that, and then I'm going to rotate down and click on this other green line that I had that was representing how this bridge was going to be rotated. Then the last step is we have to move it into place. So if you remember, you can zoom in, we tagged with our annotation callouts spot elevations at the start. The start was at 651 feet. If I go over to the other side, my end was 642 feet 4 inches. So if I click on my bridge that we just placed, you can now go into Edit Type and change your bridge elevations, the start point to 651 feet, and my end point is 642 feet 4 inches. See all that? If I hit OK, it's going to think a minute. And if I turn on my shaded view, there's my bridge. Turn on my 3D.
It looks like a fish coming out of the water.
Now, something's wrong with my canopy reference point. So I need to go back in and actually figure out that position of where it needs to be in the Z relative to some position on the bridge. But then also notice that none of the actual pipe or the rails come in because those were reference lines. Reference lines won't show. So we need to give that some structure. And I'm going to go back into this bridge file. I'm going to give you a quick little tip. Once you get this part of the bridge working, where you have all of your reference lines, you have your points, you have your adaptive components in there, you also have your canopy structures, working to some degree. I want to make basically these pipes, make like a pipe structure to look, to actually give some thickness to all of these reference lines so that they show up in the project model and I can render them in view. Typically, we would go in here, we would find a point, you'd click on it, find the actual normalized plane, that perpendicular plane. You would draw a circle and then extrude it, click on the circle and then the rail and then sweep it. If you've noticed, every time you sweep a mass object along a set of reference lines and planes, it wants to change all of your points, right? So when we did the first sweep, it took all of those points and started rotating them so that they had some perpendicular relationship to that surface. You will run into all kinds of issues if we continue modeling on this particular set of reference planes. So do this real quick and this will close out today. A quick workaround. Families new, let's make an adaptive component. Generic adaptive. And if I look at my bridge, to basically make a pipe along, let's say this top rail for instance, this top rail was made out of 5 points. I had a point here, a point there, another one in the middle, and then one over here, and one at the end. So we need to make an adaptive component that also has 5 points, and this one will be real quick. Just doesn't matter where they are, just do 5 points. I'm going to select them, make them adaptive, make a spline through them, click on it, make it a reference line. And then if I host a point, this is where you can make your pipe structure. So I can click on circle, pick that reference plane, go back to circle. Right now I'll keep it that dimension. We turn that also into a reference line, make sure they're all references. I can select those and say create form. Load this into that family. Should have given it a name. And because it's an adaptive point or adaptive component, we can place it. It was called family 1. Now I'm going to snap to each of these points. And there's my structure that will show up. Now you can take that one step further, and if you added parameters, just like we did with the adaptive components, you could give it an instance parameter that would change the radius. You'd have to make it an instance parameter, and then over here, set it to equal some parameter that's already set up in this file. And I can do that for each of these different rails, and then when I load this into my Revit project, I now actually have everything looking like a bridge with the structure and so forth. You notice, because I overwrote it and all my values were back here. 650. Okay? So this essentially concludes all the tutorials that I'll have for making of this bridge. You're basically kind of on your own to figure out your own project. I'm here by email. I'm not going anywhere over spring break. So email me any kind of questions you have, or even like most of you have been doing, if you have an error message or some problem, you upload your file, I take a look at it, and I've been commenting, telling you maybe where you might go wrong or have gone wrong and what to fix. The goal between now and the Tuesday after spring break is for you to complete your bridge and get it back into this topo model so that on Tuesday, you don't have to have it fully complete, but it's going to be fully complete by the Thursday after spring break. So I'd recommend you find a little bit of time between now and then to get as much of this in there as possible. This is kind of a test on everything that we've gone over. The one last thing we didn't do here is obviously apply your curtain panel structure to that canopy form. You're looking at a bridge that has parametric qualities, and you've added in adaptive components. So you've got these tectonic structures, and you've been working with your curtain panels that were based off of some inspiration of something in nature that you're going to apply to these canopy structures. Get a bridge or tower, whoever's doing the towers here again, into your landscape and get them working so that they're in this project file. By being in this project file, we can then go over rendering. Revit has some really nice out-of-the-box rendering capabilities. We're just going to do some quick exterior renderings. I'm going to show you on Tuesday how to set up your camera views, how to do a quick set of renderings, and then how to place them on a sheet. So that'll be the Tuesday after spring break. Will be all about that presentation format and how we can get some really nice, cool views of your bridge. And also set some basic materials to it. I'm thinking, bridges are going to be white, or you might select some materials that you want, but I'm not looking for concrete and steel structure and all that kind of stuff. We're just going to kind of have these white models over a chipboard model, and then you also have your water that's already in there. Okay? Any questions? Any issues? Remember when you do that rail structure as an adaptive component, I did real quick, I just made that one circle and then gave it a dimension. Remember, you have to go to the endpoints and also give it that same dimension. Otherwise, as your bridge grows and that form grows, you might get something that varies along its path in thickness. Okay? And then after this, we'll move on to hotels. Get into the nitty-gritty of the project environment.
Hey, Johnny.
I did.
I was trying to figure it out. I still don't really get.
People are just downloading apps and help us with that right now.
I don't have an idea.
Okay.
I'm putting it on my computer.
I'm going to plug in my iPod.
I guess what I was trying to figure out is
Because how I was thinking
so you
about
have
it.
your two, I know you have your two paths.
Yeah, I have the 2 paths. What I was thinking.
I don't have a pen.
Not bad.
Brian, do you have a pen?
No.
Yeah.
Anyone have a pen
I have a pencil.
or a pencil?
Anything?
You can draw it back.
So I have the one pair of like.
Are you gonna talk